Determine all intervals of increasing trend or decreasing trend and determine the coordinates of all maxima, minima, plateaus, or cliffs for the function f of x equals x plus cosine x. The first thing to do is find the domain. F of x equals x, a polynomial term, the domain will be all real numbers, plus cosine of x, a trig function with no denominator, the domain will also be all real numbers. So collectively, the domain is all real numbers, or negative infinity to positive infinity. Trig functions have a tendency to have an infinite number of intervals of increasing trend or decreasing trend, as well as an infinite number of maxima, minima, or plateaus throughout their entire domain. But nicely, cosine x is 2 pi periodic, which means that it repeats itself every 2 pi radians. Another way to write this is f of x plus 2 pi equals f of x. So instead of working on the entire domain of negative infinity to positive infinity, which can be a little overwhelming, we can instead work on the unit circle interval, which begins at 0. It includes its square bracket up to 2 pi. It does not include it round bracket, because 2 pi is the same point as 0 on the unit circle. Find all the results on the unit circle interval, and then extend those results to the entire domain of negative infinity to positive infinity by using the 2 pi periodic nature of the cosine x. The next thing to do is find all critical numbers on the unit circle interval. We will take the first derivative, f prime x equals, the first term is a constant times x, the derivative will be the constant 1. The derivative of cosine x is negative sine x. We can now set the numerator equal to 0 and the denominator, if there is one, also equal to 0. We can subtract 1 from both sides to solve for x here. So negative sine x equals negative 1. Divide both sides by a negative 1. So sine x equals a positive 1. We need all locations on the unit circle interval when sine x equals positive 1. That happens at only one location. It is at pi over 2. Within the unit circle interval, that will be our only critical number. We can now draw a unit circle interval line, a line representing the unit circle interval. It starts from 0. It includes 0, so square bracket on 0. Up to 2 pi, it does not include 2 pi, round bracket. We can put pi over 2 on here, which splits the unit circle interval up into 2 separate intervals. We can pick a test value in each of the intervals. The first interval is 0 to pi over 2. That's the first quadrant on the unit circle. We can pick pi over 4 in there. The next interval is pi over 2 to 2 pi. That's the second, third, and fourth quadrants on the unit circle. We can pick pi in there. We can now test the trend by plugging the test value into the first derivative. We don't care about the value of the first derivative, just whether it is positive or negative. Starting with the test value of pi over 4, plugging in, the sine of pi over 4 is root 2 over 2. Now the square root of 2 is about 1.4. And dividing that by 2, it's about 0.7. 1 minus that is certainly a positive number. So we have a positive first derivative, which corresponds to an increasing trend. Now we can plug pi, the test value for the next interval, into the first derivative. 1 minus the sine of pi. The sine of pi is a 0. 1 minus 0 is a positive 1. So we have a positive first derivative, which corresponds to an increasing trend. Now, another thing about this, the left endpoint is included, and that's because the trig function cosine x is 2 pi periodic, repeats itself every 2 pi radians. So this 2 pi point will connect onto the 0 and continue to have further and further periods of width 2 pi. But that means that this increasing interval here will also exist over to the left of 0 and connect onto it because 0 is included. So there will be a full interval starting from some value going to some other value. Now here it's going from pi over 2 to 2 pi. 2 pi is 4 pi over 2. 1 pi over 2 to 4 pi over 2 has a width of 4 minus 1, 3 pi over 2. So there's an interval of width 3 pi over 2 that is increasing that will exist to the left of 0. 3 pi over 2 to the left of 0 is negative 3 pi over 2. So there will be a full interval of negative 3 pi over 2 up to 0, and then it includes 0 and continues all the way to pi over 2 of increasing. They will connect together. And that means that we have an increasing interval, not just from 0, but all the way from negative 3 pi over 2 through the 0 all the way up to pi over 2. That will be this interval over to the left connected onto this interval because it includes 0 and connects together with it. So we have covered everything there. There are no decreasing intervals at all. Right at the critical number of x equals positive pi over 2, we have the trend on the left increasing, the trend on the right also increasing, so the trend is not changing, but it is a critical number, and if we have a critical number where the trend does not change, and it came from the numerator, that will make it be a plateau. So we will have a plateau at the x-coordinate of pi over 2. It has a corresponding y-coordinate that can be found by plugging the x-coordinate back into the original function. So y will equal f of pi over 2, which is going to be pi over 2 plus cosine of pi over 2. Well, cosine of pi over 2 is a 0, so this will be pi over 2 plus 0, or just pi over 2. And there's our location of the plateau. It's an increasing plateau. So plateaus, they have a first derivative that's 0. So they briefly go horizontal, but it's increasing on both sides. So it'll look something like that on the graph. There is the results over one full period of width 2 pi. We can now extend these results to the entire domain of negative infinity to positive infinity using the 2 pi periodic nature of cosine x by adding to each of the x values 2 pi, the period, times n, an integer. The increasing interval here is x interval. It's x values. Those are both x values. Each of those will have a 2 pi n added onto them. For the plateau point, the x-coordinate is an x value, so it'll have a 2 pi n. The y-coordinate, f of x here is x, which is an x value, plus a trig function. And since f of x equals an x value, that pi over 2 is also an x value, will also have a 2 pi times n added to it. So we have increasing intervals from negative 3 pi over 2 plus the period 2 pi times an integer n up to pi over 2 plus the period 2 pi times an integer n. And the plateaus will be located at pi over 2 plus 2 pi n and pi over 2, and because that pi over 2 is a y-coordinate coming from f of x equals x plus a trig function, it's also an x value, and it will also have a 2 pi n added to it, where n here is any integer. It can be a positive integer, it can be a negative integer, it can even be 0. If n equals 0, it'll give the results of the interval we just worked with. allowing it to be any other integer, will give the results over the entire domain of negative infinity to positive infinity.